Now, the delete statement, by the way, is different than truncate statement. Let's go look at a delete statement. I'm going to delete, for example, I try to delete this row from the table, and I'm by issuing the delete statement. Here is the format instruction of the syntax structure of the delete statement, and here is the delete statement. Delete from department where department name is equal to finance. Only I'm going to removing the information for department of finance from departments table. It is a big delete. If I delete this one, it's going to remove 22 row from my table. But this delete statement only remove one row from my table. Now, I spoke about the delete statement and truncate. If I delete asterisk from employee table, let's example right here. If I do this delete statement and proceed, it's going to delete all the row from employee table. And if you're going to notice that if I do a select statement and 51 row deleted, but select asterisk from employee, and you're going to see no row selected, but I can roll back if I do not commit it. And now that I roll back, I can select asterisk from, and you're going to see that we got the all 50 row back. So be careful when you're using the delete statement. The difference between deleting the statement and truncating the statement. Delete statement delete the row, but the row ID still exists in the table, and let's put it the space that by using the delete statement and removing 500 or 50 or 51 or 2000 row, the space is still allocated for rows. But when I use the truncate table, it's going to release that space from that specific employee table to Oracle database, and that space is reusable. But the delete statement only remove the content and replace those content with null, which is won't return anything. But truncate delete everything and keep only the structure perfect. The commit, rollback option, and save point. We have another feature in Oracle database which we call it save point, which allow me to control my commit, my insertion, delete, and update statement, which we call it transaction. It allow me to control the behavior of all of this clause. Let's talk about its explicit transaction control statement. Let's consider I have a saving and checking account, and I would like to pay a credit card bill online. For example, I taking some money out of my saving account, deposit that one on my checking account, then update and find out my current balance, and after that one I issuing a check and inserting a new inserting some more money from another checking account to my deposit in my checking account. So in fact, I can each of these transactions which is take place generate a save point A, save point B, save point C. Let's imagine as this point that I try to update my checking and my saving, I lost the power or I lose my connection to my bank. What's going to happen to my transaction? This transaction, because it's explicit transaction, it roll back everything and go to the first state. But each of these steps so roll back and stay to the beginning. However, if I proceed this is delete, insert, update, insert, and I use commit or submit, the all transaction goes together in one action. So we're going to say explicitly committing the transaction when all activity go through perfectly, or you're going to roll back if part of it failed. Now in Oracle database, when we try to do a insert delete statement right here, we can ask him to generate a save point, and we can use the save point to create a save point. We can back to that save point, or we can generate a save point B when we do update statement, or when we do the insert statement we may generate another save point. Let's look at this example. When I do the update statement, then I'm going to say save point update done, then save point generate a save point. When I do a insertion, then again I generating a save point. Well, I create a good example for this purpose. Let's consider first option that we have right here, delete from employee table where employee ID is equal to 113, and as the result generate a save point A. If I execute this option and employee ID, let me see what is my error. Well, I didn't put the where statement, that was the reason. So I delete this option. Let's consider right here, I delete, and I inserted delete twice. Let me roll it back and delete one time, and one row deleted. So let's create a save point A. At this point I'm going to say hold this action up to this point and generate a save point such as A for me. While I do a delete, I'm going to do another insertion now. After this example, I'm going, after the first this transaction which is start, I did a delete statement. Now I'm going, let me show it to you so you be sure you're going to see everything. So I did the first delete statement, and right here I generate a save point A. The same second transaction I do the I going to do right here a insert statement, and this time I'm going to insert to the department. Consider this one, the first one was employee table, this one is department table. I'm going to insert a row into the department table. When I go insert a row to the department table and proceed, one row inserted. At this point I'm going to generate a save point B. So I'm going to generate a save point B. I create a save point B. The third action I'm going to do right here, let's see, the third action I'm going to do, update the department table and set the location ID to 1700. Update department table, set location ID to 1700, but unfortunately I didn't use a where clause, so we're going to update everything to 700. Let's fix this problem. I change it where the department ID is equal to 201. So I'm going to copy both and generate a save point C in this example. I insert it and generate a save point C. I do the last one and generate the insert into the employee table and generate a save point D. So as you're going to see right here, I have a D, and let me see what is the problem. Let's go ahead and do a insertion first, and the row is inserted and generate a save point D. I generate a save point D. Now if I'm going to say right now roll back to A, so you're going to take all this action that I had back and go to the before I start doing my first delete statement. If I going to say roll back to point A, so I'm going to lose all this piece of activity that I did, and it's going to roll back to the beginning. If I'm going to say roll back to the B, it's going back to this point and stop up to this point right here. And if I'm going to say roll back C, it's going to stop right here, and all this action is still take place. And D the same way, you're going to roll back to right here. If I do commit, all this action that I did take place is committed. So at this point I'm going to say roll back A, and it's going to take all my action back to a square one. So roll back to A. I have to issue roll back to save point A, not just roll back to A. And I misspelled. Let me see what. Here you go. And save point never establish. Roll back to save point A. See, if you're noticing, you put save point and A next to each other. When I copy paste, I'm going to write it like this one. I'm putting in the next line so you're going to understand this option. And rollback completed. And all my insert, delete, and update these 4 transactions that I did is rolled back. If at this point I'm going to say commit, then it's going to commit all the transactions that I did. Now, we spoke about the DDL and DCL. We are not going to talk about DCL and DDL, especially DCL. We're not going to cover it in this course. But the reason we mention it about the DCL in this slide, in this module, because what's going to happen if I did a save point, generate some save point. I did a transaction, but during my transaction I did a DDL statement. I create a table. Let's go back to this example right here. I did a transaction, but before I commit a transaction I did a DDL. It means I create a table or alter a table, drop a table, one of these 3. Based on the Oracle rule, your transaction will be committed regardless of doing a DDL or DCL. Your transaction commit. Any DDL and DCL, commit your transaction. And here is the full all the concept that you're going to cover in much more detail. I'll let you to read that. Also, advantage of read and commit and roll back. Here more rule about implicit transaction processing and more about commit and roll back. And here is the logical description of what happened after a save point. Well, when you insert a row into the table and you do not commit, or transaction not committed totally, there is a lock in each of the piece of the statement that you executed, or piece of the transaction that you're processing. And as long any other user accessing the data, they gonna see the old data. They won't see the new data that you inserted, deleted, or updated, unless you committing the whole transaction. When you commit the whole transaction, the lock will be released and other user they can view the change. Read consistency. When you try to insert, delete, or update a table, what's going to happen if another user attempting to read from the same table that you try to insert row to that table? Well, that user can see read the old data without any difficulty. But what's going to happen when you try to delete a row from a table, and let's put it inserting or updating a row in a table, and another user try to update the same row that you attempting to update. So there is always whoever grab the lock first, you're gonna have require a lock to do the update statement. So as long the other user did not commit or roll back, you cannot update or delete the same row that already locked by another user. And here is much more detailed graphic format for implementing read consistency. Finally, it's a for update clause in a select statement. This is another structure that you can update a table by using a select statement. And in fact, what you're going to do, this select statement, because we use for update right here, you're going to lock the job ID for sales representative, cell REP. And as long you do not commit or roll back, this row for job ID is blocked or locked by the active user, the user that try to do this update statement, or this session that try to do this update statement. Here is another